This is just a review for the ACS final exam. As I stated before, it's 60 questions for 55 minutes. So each question is less than 1 minute, about 56, 57 seconds. So let's start with the first one. The first question here, it says, when a substance undergoes a chemical change, it's always true that we are talking about chemical change, correct? It changes, it melts, it changes its state, it's changing its chemical composition, it's changing its heat status, or it smells. Which one is the most probably the correct answer out of this? What's that? C, its chemical composition changes. Correct. C is correct. All the rest is the physical changes. Are you following me here? All the rest, A, B, D, and E, that's a physical property or changes. Correct? So, number two. Number two is, which molecule below is both heteroatomic and triatomic? Heteroatomic and triatomic. Now you have to watch for the wording here. Triatomic means 3. So tri here, the prefix tri means 3. Correct? Hetero means not the same. Homo means the same. Hetero means different atoms. So hetero, that's again is a prefix. If I say homoatomic, means similar atoms for the same element, correct? Heteroatoms means different atoms of different elements. So hetero means different. So what do you think is here? We have, let me take this one here out. So which one? B, we have triatomic. We have, look at this again. Let's look at the first one. How many atoms we have? How many atoms or how many elements we have? 3. So this one is 3. Same or different? Same or different? Different, okay. How about the second one? How many atoms we have? How many? 4, correct? 4. 3 oxygens and 1 sulfur. So we have here 4. Some of them different, some of them, okay? So they are different. Although oxygen is similar, but all in the whole molecule, they are different, correct? Although oxygen is the same. So, number 3, how many atoms we have? We have 3. But they are what? Same. How about D? How many atoms we have? How many atoms? 5. 4 hydrogens and 1 carbon. This is 5. And they are different. Although we have carbon and hydrogen, it's not the same atom, not the same element. But hydrogens, we have 4 similar hydrogens. But all in the whole molecule, we have 2 elements that they are different. Correct? How about E? How many atoms we have? 4. And they are the same? No. We have 2 elements, 2 different atoms, nitrogen and hydrogen. So they are different. Now, out of this here, when you analyze all these all these options, you get into the question is you are looking for tri. This is 3, and hetero means different. So which option is 3 and different? Which option is 3 and different? A. The answer is A. It's not a B. It's not a B. B, we have 4 atoms. We have all in all 4 atoms. Correct? And different. Yeah, of course, we have oxygen atom and sulfur atom. But the answer will be A. So the answer is 3 different ones. Hetero, if I say homo, homo means like homogeneous mixture. The distribution of the pure substances is when you have homo is fixed throughout the distribution. You get one layer, you can see only one layer. If you have heterogeneous, the distribution of pure substances within the mixture is not fixed. Okay, so you'll see more than, depending on the pure substances inside the mixture, you'll get more than one layer. You can get 2 layers, 3 layers, 4 layers, depending how many substances of pure substances inside the mixture. So A is the correct answer. A is what? The correct answer. So, number 3. In which of the following sequence of elements do all members of the sequence have chemical symbols starting with the same letter? That's a good thing. If you look at the periodic table, you have in the same the keyword is the keyword here. Look at the keyword here. What's the keyword is? You have sequence of elements. That's the one. The second one, they have to have a chemical symbol which is with the same letter. So we have sulfur, silicon, and sodium. Okay, sulfur, silicon, and sodium. All of them start with, correct, with S. Gold, silver, and aluminum, this we can eliminate this. This is out. Why? Because they don't start with the same alphabet. So we'll leave the one with S. Tungsten, telluride, we keep this one here because they start with T. Iodine, iridium, and iron. So we'll keep this or this. This will be eliminated. Potassium, phosphorus, lead, that's out. We'll keep this one here because starting with T, starting with I. So, but the key word is following sequence of elements. So, the sequence of elements can be, look at this, can be within the period or within the group. You can look at it whatever you like, but it can be within sequences within the period. So within the period you have sodium comes first, correct? So then if you look at the period, sodium, then comes silicon, then comes sulfur. So that's not the sequence we have, correct? You have sodium. I'm looking at a period in the periodic table there, out there. In the third period, I'm looking at the period. Because if you look at the group, there's no match. Silicon is group 4 and sulfur is group 5 or 15, correct? 14, 15, and then sodium is 1. So they are not, but we are looking at the period. So this, we can eliminate this as well because it has to be sodium, silicon, and sulfur. So if this is correct, start with sodium, then you have silicon, then sulfur. So that will be the sequence, correct? So we eliminated 3. Now we have tungsten, tellurium, and titanium. Let's look at this. Where is titanium? Titanium is so titanium is in 4B, correct? 4B. If you look at this, This is transition elements, if you look at it like this. And where is tellurium and where is tungsten? Tungsten is all the way in the heavy metal. If you look at tungsten, where is tungsten? Somebody will tell me where tungsten is. Maybe I have to look at the periodic table, and then if I tell you this, you are not following me. So let me here. Just hold on here. I'll say black and white. Black and white. Periodic table. That's better, so you don't have too many colors and all this. Okay, so here we are. So I'm taking those out, taking the exam. So now we are looking at the not this question. We are looking at. Just hold on, guys. Number 3. Tungsten, tellurium, titanium. So here it is. So look at this. And then the last one is iodine, iridium, iron. Iodine, iridium, and iron. Iron is all the way, it's not the same sequence. Iron, iodine, and iridium. So let's look at the iridium. Where is iridium, guys? Iridium has to be in the iodine is here, atomic number 63. Iron atomic number is 26, and iridium, that's indium, tellur, and iridium is 77. So iron, iridium, and what? Iodine. Well, it looks like this will be the best option we have, because no, iodine, iridium, iron. How about tungsten, tellurium, titanium? Let's look at this. Tungsten is that's bismuth here. Tungsten is near bismuth and near lead. That's iridium. Tungsten is 74, guys. W. Tungsten is W. Okay. And then you have tellurium and titanium. Tellurium. Titanium is here. Tellurium is here. And 74, 22, correct? And what the other one? Titanium, tungsten, and tellurium. Tellurium is, here it is, guys. Yeah, those type of questions, they tend to lose a lot of time. So don't waste your time. Come back to it. It's 83. So you have titanium, tungsten, and tellurium, correct? But the sequence is correct. It does not really matter. The main thing is, are they in the same period? Even if they are not the same period, they should you look at the groups. The first group after the second group after the third group. It looks like number E is not correct either, because iodine is in the 7th group. Iridium, we said in the iridium is somewhere here in the 8B group, 77 atomic number. Can you see it here? It is. That's iridium here. Let me so to see. We'll do one option at a time. So those type of questions, I'll skip them. Why? Not because I can't solve them. You'll solve them, but they will kill your time. They will kill your time, because you have to figure out one at a time. You have to go through all these options and circle in your brain here on a piece of paper, scratch paper. This is, let's do the last one here. We have the question here, so I will keep this one at the last. I will not bother myself with it. So iodine, iridium, iron, iodine, iridium, iron, iodine, iridium, whoops, here guys, iodine, iridium, iron. So I will circle. Iodine is here, different color. So let's do a different color, and then you can pick up this quickly. Iodine, iridium, and then iron. So start iodine, iridium, iron. We will want to see it iron, iridium, iodine. This is the sequence 8. This is 8B iron before iridium, and then iodine will come. So the next one, let's go one after a time. We'll do the same options here, guys. Just bear with me a little bit. So then tungsten, tellurium, titanium. Tungsten, tellurium, titanium. So tungsten, let's move the color, different color. So here it is. Tungsten, which is this one here. Tellurium, and what? That's the last one. Which one? Titanium, correct? Yeah, titanium is here. Titanium is here. So, okay, so but you have to look at the sequence is. So will be the good sequence will be whether reverse or not. Titanium will come first. This is 4B, and then 5B, 6B tungsten, and tellurium is 8A. So if you look at this, that's one. How about another option? Let's take another option. Another option is gold, silver, aluminum. Gold, silver, and aluminum. We did not look at this. Gold, silver, and aluminum. We'll give it another color, guys. So gold, silver, and what? Aluminum. So this is 1, this is 3, and iron was 3, correct? Iron was 3, and iodine is 1. Yeah, I don't like those type of questions. It's not really difficult. The problem with them is takes your time. It takes. I'll skip this one here until the end. So it kills your time here, and that's you have to get out of it. So you have iron is number 3. Again, iron 3, correct, and iodine is number 1. Iodine is number 1. So it is. Iodine is number 1. Oops, sorry. Iodine 1. And iron is 3. So, and then we have the blue one. Let's look at the blue one. The blue one is, this is tungsten, and then titanium is the number 3. So you have tungsten, and tungsten is number 1. Oops, sorry. Tungsten is number 1, correct? Okay, guys. Tungsten is number 1. And as I said, those type of questions, I will skip them. And then titanium is number 3. Titanium is number 3. Titanium is number 3. Yeah, those are, I don't like those type of questions. It's just, it will be not fair for you to spend your time circling all choices and look which one is the best. The similar sequence, not the opposite sequence, will be, you start with the first, look at the groups. This is this is 3B, 4B. So this one has to be 1, and this one has to be 2, and this one will be third one. In the red one you have, this one will be 1 and 18, but I have 4 in group of 18, there's 3 of them. This is 1, this is 2, this is 3. And here we have, you have gold and silver. This is 1, 2, and then 3. However, until now, those 3 options we don't have. Let's look at them. You have 6 options, A to E, correct? So, let's look at the silver, silicon, and sodium. Silver, silicon, sodium will be, let's give it another color. Silver is here, 1. Silicon is here, 2. And silver, silicon, and sodium, 3. So until now we did not get the sequence. So we get them, all of them, but we did not get the sequence. So if we get the sequence, will be sodium first, and then silicon, and then sulfur at the end. So let's see. How about potassium, phosphorus, and lead? Potassium, phosphorus, and lead. Let's look at this. Looks like this is our option. Potassium will have another color. Potassium is here. This is number 1. And what you say? Potassium and what? Potassium, phosphorus, and lead. Potassium, phosphorus is here. There it is, guys. Phosphorus is here, 2, and lead is here, 3. Are they in sequence? No. It has to be potassium, then lead, and phosphorus. If you look at the groups, but the best one will be number 3. You have sodium, silicon, the same period, but they are not in the sequence. So unless we read the question wrong, have we did not have the chemical symbols, not starting with the same thing, with the same letter. So, well, the first one is there. Oh, sorry. This is out, not the same letter. The starting, this is starting, correct? The keyword starting. So this is out. We have only this. And this is out, not the same. And this and this. Well, we look at this again. The only thing I can say is, with the sequence will be titanium. Titanium start. This is 3. Titanium, and then I think that the answer is titanium, because potassium, phosphorus, and lead. Phosphorus is E, that is an E, potassium is E. The same. So I think the blue one is the most correct one. The blue one, which is titanium, that's the answer, I think. That's the answer. Okay, you can check it, but that's the answer, because the silver and gold. If you look at this, you have iodine, iridium, and iron. So let me see. Hold on. Iodine, iridium, and iron. Well, I don't know what's the sequence here. I can look at the key, but some of the answers are not correct. To tell you up front, some of the answers in their keys are not correct. Now, what we mean by similar sequence? Are we looking at the same periods, or are we looking at the groups in the sequence? So we don't go for example, here guys, when I look at the iodine in the 8A, then I look at the other iridium is 8B, and then I look at the other one, iron, correct? Iron, iridium, and iodine. So those are not in the same sequence, because they are different. Will be this is first, second, and third. The other one, which is thallium and tungsten, this is the first, second, third. Correct? The lead and the other ones are not the same. Those are coming different. So we have the red and the blue are correct. But to tell you the truth, both of them are not silicon, sodium, and sulfur. Sulfur is come first. That's a reverse sequence. It has to be sodium comes out, group 1A, then silicon group 4A, and then group 6A. So I would say from whatever I have here, the third one will be first, but the sequence is not there. So I'll skip this question if it's there, but it will not come. ACS exam will never do something like that, and their answers themselves are wrong. Some of the answers are not correct. So when I say to you sequence means I'm looking for the same periods, the same groups, or groups attached to the third group, fourth group, fifth group. I cannot jump from the first group and then the third group and then come the second group. That's not a sequence. Are you following me here? Anytime you say sequence in chemistry, you are following order. 1, 2, 3, 4, 5. You cannot say 1 and then jump to 9 and then come back to 3. That's not. So, well, I would say 3 is at least the blue one is very close to be true. But for me, it will be good to have sodium, silicon, and sulfur but I'll switch. So there is a typo, or there is the answer. The question is not correct. So I'll put this one here. The answer is A if I will rearrange the sequence. They're starting with the same symbol, correct? But then sodium will come first, correct? Sodium will come first, and then silicon second, and then sulfur is third. So the real answer is A if they follow the same sequence. So anyway, I'm not spending time on this. Yes, any question you have. As I said, that will not come in ACS. I have never seen it, because their answer is not correct. And you'll see a couple of those answers are not correct. Okay, guys? There is no sequence here. Sequence has to be within the same period, the same group, or the period is close to each other. Third period, fourth period, fifth period, or third group, fourth group, fifth group. There is a sequence, but I don't see any sequence. They jump from the first period to eighth period or sixth period, then come back in the fourth period. That's not the sequence. But anyway, so don't worry about this type of question. Them themselves is, so number 4. As I said, there's some error inside this. So what is the total number of atoms present in one molecule of Al2SO4 What the total number of atoms? Did I say heteroatoms? No. Did I say homoatoms? No. I said what is the total atoms? That's the key. The keyword is there is no homo, similar. Okay, if I have the similar, then I have to look. Only oxygen is similar, correct? And 12 atoms of oxygen. 3 multiplied by 4. So if you look at this one here, so I'm looking at this. If I say HOMO, I'm looking at the oxygen. That's a HOMO. Same. And those are how many? 3 multiplied by 4. You have 12 oxygen atom. But here the keyword is total. So how many total we have? Look at this again. 2 aluminum plus, correct? 3 multiplied by sulfur, 3 sulfur, plus 3 multiplied by 4, 12 oxygen. So how many total we have atoms? I did not specify whether it's homo or hetero. I did not specify. I need the total of all present. So how many total we have? How many? The option, the answer is? The answer is D. That's correct. Are you following me? You have to watch for the keywords. If I ask you about homo atoms, that's the similar atoms, which is oxygen. Hetero atoms, they are all these three types of aluminum, sulfur, and oxygen. So the answer is D. So number 5. Number 5. Consider the chemical formulas. This and this. We have this and this. What's the difference between those two compounds? Somebody will tell me, please. What's the difference? This is what? This is ionic, guys. Why? Because CO, capital C, small o, that's cobalt. This is a metal. So this is ionic. So this ionic. How about this one here? This is covalent. It has carbon, oxygen, and chlorine. No metal there. The metal, this is a quiz for us to know the symbols in periodic table are written in 2 alphabets. The first one is capital letter. The second alphabet has to be small letter. You cannot have both capital letters, correct? One is capital letter, the other one is small letter. And this is a metal, and those are 3 different heteroatoms: carbon, oxygen, chlorine. So consider the chemical formulas in which statement is true. Here it is. Let me see. So can I take this one out? I'm taking this one out. So I'm recording anyway, so you can follow the whole thing. Which of those statements, A, B, C, D, and E, is correct? Yes. Yes. Lewis structure? Okay. Well, that's a good question. If you have 4 elements, you have to watch for the octet rule. Okay, so what are those elements if you remember? Those are 4 elements. This is a must. They do have a must. We have carbon, correct, nitrogen, oxygen, and fluorine. Those are 4 elements. They have to have octet rule. Octet rule means they have to hold octet rule. Now, octet rule means they have to have 8 VEs, 8 valence electron, whether as combined or not combined, whether bonding or non-bonding. Combined or bonding here. Bonding or non-bonding. Bonding or non-bonding. So now, sometimes those 4 will not obey the octet rules when they start with single bond first. Any Lewis dot structure start with single bond. So then you are forced to do what? To satisfy the octet rule for those 4 elements, to go to this double bond. If the double bond will not satisfy octet rule, you go for the triple bond. then one of those double or triple bond will satisfy the octet rule. Are you following me here? So for example, if I have, let me just show you here. I have compound looks like this, C2, C2H2, correct? And I have a compound says C2H H4, and then I have a compound looks C2H6. So now how in the world I have only seen of here, I have carbon, nitrogen, oxygen, and fluorine, correct? So the only thing is I have here in those is carbon. Hydrogen always at the edge, terminal, at the edge, connected to one. So for this one here will be C, H, H, that's two H's, sorry. So that is, so this is one H here, one H here. So one H here, so. Well, it does not want to. Let me take this one here out here. Can I take it out? Let's look at this. C2H2. So I write this one here, H, H. But then the carbon has 4 valence electrons, correct? Hydrogen is 1. Hydrogen is 1. Carbon has 4. But carbon has to obey octet rule, correct? So I say, well, it's not obeying octet rule. I will move this one here. I move this one here, make a double bond. So this one will be looking C, double bond C, and then one is still here, one here, one here, one here, and then one here. So is carbon obeying octet rule? Let's check it out. I have combined and non-combined, 1 and 2, 3, 4, 5, 6, 7. So the double bond will not do it. The same thing with the other carbon is a 1, 2, then 3, 4, 5, 6, 7. So each carbon is 7. So what I will do, take now this valence electron, put it here, put this one here, and make what? I'll make a triple bond. Single bond will not satisfy octet rule. So then the problem is solved when I have triple bond looking like this. So then I have, each carbon will have 1, 2, 3, 4, 5, 6, 7, 8. The same thing here, 7 and 8. So each carbon has 8, and this is satisfied the octet rule. So really what's controlling us, the octet rule is, the double or single or triple bond is the octet rule. So now, if I have the other one, let's look at the other one. Can I take this one out? You have it? You have it? So let's take this one out and look at, yes. Sulfur oxide, when I write sulfur oxide will be, we have 2 sulfur oxide. Sulfur dioxide and sulfur trioxide. Now, which one we have to take care of? Sulfur? No, we don't care about sulfur. Sulfur can violate the octet rule. We don't care. But we care about what? Oxygen. Remember this? Remember those here, 4 elements. Oxygen is one of them. Yes, we have here. In the previous example, we have carbon. In this one, we have oxygen. So oxygen has to have, oxygen 6. So I will have, first, put this one here, put this one here, put this one here. This is 1. Oxygen has 6. 2, 3, 4, 5. This 1, 2, 3, 3, 4, 5. So 4, 5, 6. Correct? So let me see. 1, 2, 3, 4, 5, 6, 6. And here we have the same thing here. 1, 2, 3, 4, 5, 6. Is oxygen is obeying the single bond will satisfy the octet rule. We don't care about sulfur. That's SO2 or SO3. I'm looking at SO3 now. 3 of them. I'm looking at this. So if I look at the number of the octet rule, I have 1, 2, 3, 4, 5, 6, 7. So I have what, guys? I have 7. Each oxygen will have 7. So that's not good. I have to have 8 for oxygen. Sulfur, we don't care. So what I want to take this one here to make a double bond. If the single bond not do it, let's try with the double bond. So I'm trying here now to make the octet rule for oxygen satisfied. Now let's look at, we don't care about sulfur. Sulfur is violating the octet rule. We do care about the oxygen. 1, 2, 3, 4, 2 sets of non-bonding, 5, 6, 5, 6, 7, 8. This is holding octet rule. This is 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. This is okay. And this is the same thing. 1, 2, 3, 4, 5, 6, 7, 8. This is okay. So SO3 will be S, O, O, O. This is the Lewis dot structure of sulfur trioxide with the double bond. How about sulfur? Sulfur has 12. Look at this. Violating the octet rule, but we don't care about it. So it has, sulfur has 1, 2, combined and non-combined, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So sulfur has 12, 3 sets of double bond, bonding double bond. So it has 12 valence electrons. But we don't care about sulfur. We care about oxygen. Yeah. So it's a double bond. Let's look at SO2. So I have here OO. So your tuition will tell you this is now will satisfy the oxygen. Okay, so this is will satisfy the oxygen here you have. So here it is. So here, so let's count for each oxygen. Same thing, the other one will be 1, 2 sets of non-bonding. 1, 2, 3, 4, 5, 6, 6 here, 7, 8. So each oxygen has 8. This is obeying the octet rule. How about sulfur? Sulfur has 6 valence electrons. So this is 1, this is 2, this is 3, this is 4, and 1 set of non-bondings, 5 and 6. So this is SO3 and this is SO2. We don't care about the sulfur, we do care about the oxygen. We have to look at the 4 elements here, and if the double bond does not make it, the triple bond will make it. So single bond first, we try it, then double bond most probably will fix the problem. If the double bond is not fixing, then the triple bond will fix the problem. Now we'll answer a question. Okay, so let's go back and look at the exam here. You did not answer to me. You said we have ionic, cobalt. What we call this compound? Come on, guys. That's another question here. What do we call this compound? We said ionic, correct? What do we call it? Capital C, small o. That's cobalt. That's a metal. So cobalt what? Cobalt comes in multiple charges. Cobalt 2, cobalt 3, correct? This is cobalt what? The 2 here is coming from the cobalt. So cobalt, bless you, cobalt 2 chloride, correct? This is cobalt 2 chloride. How about this one here? It has a name, but don't worry about the commercial name. But if you wanna name it covalent, what you will name it first? What you will name it? The central atom is your carbon. So if you look at the Lewis structure of this compound here, you have two elements of synop, carbon and oxygen. We have to take care of it. So your intuition will tell you this compound has to have something looking. They have to have the chlorine has 7 valence electrons, and this will satisfy the octet rule for oxygen and carbon. Carbon has 8, and you can see carbon has 8 and oxygen has 8. Carbon has 1, 2 from the single bond, 3, 4, 5, 6, 7, 8. Oxygen has 1, 2, 2 sets, 3, 4, and then 5, 6, 7, 8. Okay, so oxygen, carbon, they obey the octet rule, and this is the formula of it. So your intuition on this name, it has specific name, but you don't worry about this name here. It has a commercial name, phosphine. So, but you can say this is what? Cobalt 2 chloride, and this is? In this case, if you don't know the name, what will be your central atom is carbon, correct? The core of the molecule is carbon. So carbon, oxygen, dichloride, correct? Carbon, oxygen, dichloride, if you don't know the commercial name for it. So carbon, oxygen, because you have two ones, and then the other terminal is chlorine. So carbon, oxygen, chloride. Okay, guys, so now that's the naming. But I want you to answer to me the question. You look at both formulas. What the true statement about those two formulas? Which the answer here? Are they containing the same elements? No. One is metal cobalt, the other one is non-metals, carbon, oxygen, chlorine. Not the same number of elements either, correct? Are they identical in meaning? No. They contain different number of atoms. Well, I will have to recheck this one again. Sounds not bad. Yes, they have different number of atoms. They are both examples of homoatomic molecules. Are they similar atoms? No. Okay, so A, B is not correct. D is not correct. C might be correct. Let's go and look. We have to consider all the stuff. They are both examples of homoatomic. D is out. So the only thing until now is C is holding. They both contain metallic elements? No. So the answer is what? The answer is what? Is C? The answer is C. Are you following me here? That's the correct answer. That's the correct answer. So this is 5. Let's go and make 6. Which of the following quantities is not expressed in metric unit? Which one is not in metric units? Come on, guys, don't let me down here. You know the metric, you know the English, and you know the SI, correct? By now, I hope. Which one is not a metric one? Look at this. Metric has always prefix of the power, correct? Kilo 10 plus 3, milli 10 minus 3, correct? Mega 10 plus 6, giga 10 plus 9, and so on. So you look at this. First, kilometer, that's metric. Acres, I don't know. I'm just debating of this. Temperature centigrade Celsius, that's metric. This is metric. 5 liters metric plus SI. SI is borrowing a lot of units from the metric system. The amount of aspirin in a tablet is milligram. That's metric. So the only left is what? Always elimination. Is the only left is A. Acre is what system? English. Okay, English. Acres is what? English. The metric will be, this is area. Acres are area. Whenever I have area, is unit square. You square your unit. If you have volume, you cube your unit. So unit is cubed. So here it is, the volume here in, say, centimeter cube. That's the volume, cube. Area is, we'll say centimeter square. Correct? So acres has to do with, that's an area. So I'll say, oh, I have a backyard, a quarter acre. That's area, not the volume. That's area. Area is 2 dimension. A cube, I mean the volume is 3 dimension. Okay, you have the depth, which is the width, the height, and the length. But the area does not have the height, it's flat. You have the length and the width. Okay, there's no height there. So therefore areas are always square, square, and the volume is cube. Correct? So that's acre is an English system. So, which is equivalent to centimeter, whatever is, or meter square, or whatever, kilometer square, any units of metric square. So, 7. The number point, then decimal 00300 expressed in scientific notation. First of all, I want to tell me, how many sig figs do we have here, guys? How many sig figs? How many sig figs here? Come on, guys. Don't let me down now here. How many? 3. Everybody agrees? I agree. That's 3 sig figs. And we know why, correct? Those zeros here at the end, they are significant because they are meeting the 2 requirements at the same time. The decimal is present as well as they come after whole number, correct? If one of the condition is missing, then they are not significant, correct? Remember that. The zeros after the last zeros, if they are failing the decimal or whole number, then they are missing the condition to be considered as sig figs. But we have whole number, which is 3, and we have the decimal, so they are such significant. There are 3. So this number is expressed in scientific notation, becomes what? Becomes what? Which one? How about A? A is correct too, yeah? But why is A not correct? Value-wise, from the answer, from the value, it's correct. It's 3, correct? But we have issue with what? Sig figs. The 3.10 minus 3 is 1 sig fig, but we have our answer is, our number, it has to have 3. So which one will be? This will be. If you go to the left, the exponent will be positive. If you go to the right, which I went it this way, then the exponent is negative. Correct? So that's, and you have to observe the sig figs. So 8. In which of the following pairs of number does each member of the pair contain same number of sig figs? This one was in the exam as well, but one of the quizzes, but some students, they did not get it correct. So you tell me, look at those pairs and tell me which one they contain the same number of sig figs. The first one, can we eliminate? Is correct or non-correct? The first one, guys. So this is 3. This is 4. So this is out. Correct? Not the same. How about the second one? This is 1. This is 4. We can get this one out, 2. How about the other one? The other one is what? Is 2. This one is 2. This one is 2. That's it. This one here. Okay, guys. How about D? D is 1. and 2. So this is out. E is, we have 3 here, and we have 4 here. It's out. So the only left is C. The only left is C. Okay, guys? The only left is C. Okay, so 8. 9. What is the density of ethanol if 80 mL has the mass of 63.3? So, how I can approach this? What's the definition of density? Somebody still remembers? From the lab, correct? We have final lab today, final exam lab. So density is what? The ratio of what? Mass over volume, correct? Mass is 63.3 grams. And volume is 80.0 ml. You have to watch for the sig fix. 3 sig fix, because without the sig fix, then we have a problem. This is 3 sig fix. So our answer has to be what? 3 sig fix. So 63.3 divided by 80. So how much is it? I don't know. You can calculate. But it will be less than 1. Less than 1. So without looking, bigger than 1 it can be. So this is out, this is out, this is out, this is out. Did I calculate? No. And that's what, by inspection, I can't tell. This has to be the correct answer. 63 divided by 80, the answer has to be less than 1. Less than 1. Correct? Because 80 is bigger than 63. So the answer is less than 1, so that's the answer. Did I calculate? No. You can calculate and verify, your answer will come the same thing. Correct? Came out the same? Did you check it out? Somebody had checked it? No? Yes? Somebody? No? Yes? Okay, so that has to be the answer because 80 is less than 63, so the answer will be less than 1. So anyway, let's take number 10. Add the following quantities using the correct number of sig figs. Okay, guys. What we have to watch here, adding and subtracting, I look at the number of the digits after the decimal. So here, how many digits I have? 1 digit, correct? Here, how many digits I have? 4, correct? 1 after the decimal. Here, how many? How many here? 5. My answer has to have what? 1 digit after decimal. Should I do it this way? So this one has no digits, so eliminate. Correct? This one has no digits, eliminate. This one has too many, eliminate. This one has too many, eliminate. My answer is this. Do I do any calculations? No, I'm not wasting my time doing calculations. You are laughing, but that's really true. I'm saving myself. You have 60 questions and you have 55 minutes. So do I do any calculations? No. I'm expecting, looking, I have my answer, the least digits is 1 digit after the decimal. This is the 1 digit after the decimal is here. This 0 is 1 digit after the decimal. And you can verify it, and that's the correct answer without any calculation. You don't have to waste your time with calculations. And remember, with the sequence of this, leave it until the end. Don't worry about it. Don't stuck on one problem. Just keep going. Keep going, keep going. And do not waste your time doing calculations. Elimination, elimination, elimination. Correct? Elimination. So, number 10. So, number 10. What is the correct isotope symbol for the element that contains 7 electrons and 20 neutrons? So, if this element is neutral, then the number, it is, and this is very important, neutral element in the periodic table, neutral element. So we have number of the protons equal number of electrons, correct? So 17 electrons will be will be 17 electrons, will be 17 neutrons, correct? Then this is the atomic number. You can't say this is atomic number. And this is atomic number. Atomic number is at the bottom, smaller value at the bottom, and it's the number of protons, because it's neutral, correct? Equal to number of electrons. So our element will be X. I'm not looking even at the question. X, and then I have here 17. The bottom here has to be 17. That's the number of the protons. To do any calculation? No. And then I have the atomic mass at the top. Atomic mass, that's atomic number. Atomic mass, number of the protons plus number of neutrons, correct? Number of neutrons. So this one here is 17 is number of protons, and 20 is the neutron. This is 37, and this is the atomic mass. So this is 37 at the top. Do I have one like this somewhere? Where is it? Where's my option? Which option is correct, guys? C? Somebody said C? The answer is correct. Are you following me here? Just analyzing the whole thing. Atomic number is number of protons or number of electrons in a neutral element. Then atomic mass is number of the protons plus number of neutrons plus number of protons. 17 protons and 20 neutrons, you add them up, 37, and the atomic mass in the top is always bigger than the atomic number. Okay, guys, so um, 12. The modern periodic table arranges the elements in order of what? What do you think? Which one here? Year of discovery, size of the nucleus, increasing number of protons, increasing of reactivity with oxygen, physical state at room temperature. The periodic table is organized after increasing atomic numbers. An atomic number definition is a number of what? I want to hear it. What's the atomic number? Equal to what? We just finished one example. Number of protons. Number of protons. So the answer is here what? What's the number here? The answer is, or we can increasing number of, instead of this, we can say increasing number, take this one out, say increasing number, increasing atomic number, which is number of the protons, correct? Atomic number or number of protons, this is the same thing, correct? So number 13. Which element below has the largest atomic radius, is the biggest? Rubidium, francium, tellur, hydrogen, and silver. What do you think? Which one has the largest? How I can tell this is the largest or not the largest? What do you think? Come on, guys, don't let me down. The larger the atomic number, the larger the what? The element in periodic table, correct? So if you look at so if I look at any of those here, so look, atomic number increase, this is atomic number. This is an increase. And here is atomic number decreases. atomic number or atomic radius, not atomic number, atomic radius here. Atomic radius. That's atomic radius. But how about the size? The size will depend again with the same thing with the size of the atom itself. Correct? So let's look at the four we have. What are those? We have lead, francium, tellur, hydrogen, sulfur. Lead, you tell me. Lead, please tell me here so we can follow it here. Lead, this is what lead here. Lead here. Correct. Tellur. Okay, guys, which one more? Come on, guys. Francium. And what? Sulfur. We have still 5 minutes, guys. We have still 5 minutes. So, tellur, lead, sulfur, and hydrogen. So, now, this is the atomic radius. However, when I say the size, I have to include what? The neutron, because the size of the atom. So I'm looking at the atomic masses. Which one has the largest atomic mass of all of them? Francium has 233 gram per mole, or AMU, atomic mass unit. So this is the largest, correct? This is the largest. Atomic radius as well as atomic mass. We are looking the size of it, not only the radius. The radius is just looking at the protons, but when you look at the size, you have to look at the whole thing. The mass of electrons are small, very tiny, so you can discard them, but the atomic mass is very crucial. So, which is the second one? This is number one. This is the last one. This is the smallest one. Hydrogen is the smallest one. Correct? And then this is number one. Sulfur is 107. This is number two. No, that's number two. That's the largest. This is three. This is number four. And the last one is number five. So hydrogen is the least one, and francium is the largest one. Okay, guys, so let's look at the questions back again here. So, which one? Which the answer is? The largest one will be? Which one, guys? Remember that? With 233 AMUs. AMU, atomic mass unit, or gram per mole. AMU or gram per mole. That's the largest. 14. What is the correct electron configuration for chlorine? Chlorine, how many the atomic number of chlorine? What's the atomic number of chlorine? 17. So we have to accommodate 17 electrons. So here it is. We have to accommodate 17 electrons here. So 1 S2, correct? 2 S2. And chlorine is in the third. So 2 SP, correct? Now the third has to come in. 3 S2, 3 B. So how much left of the 17? How much? How much is it? 5. So the valence electrons are found in the last outermost. Those are orbitals hosting our VEs. Our VE is equal to number of the group, which is 7, equals 7 VEs. Okay, guys, so which one of this option is correct? Where is it? So D, we don't have D. This is, we can eliminate. D, we don't have D. We can eliminate. Correct? And we have 3S, 3P. We can eliminate this. We can eliminate this. What's left? Which one? Is what? Is C. I'll stop here because I have to upload this one here. So this is just a review for the exam, and when we come Monday, we will continue. We stopped on the 14th, correct? Those are 50 questions, and those are really very close to the final ACS exam. Okay, guys? So I'll stop recording here.